Did you got the clarity? Any doubts?
No.
Okay. Okay. Next, coming to the data type, register data types. In register data types, we have synthesizable and non-synthesizable. Okay. Coming to the synthesizable, reg data type is the synthesizable. Okay. Here A is storing 4-bit value and B is storing 7-bit value. Okay. 3 down to 0 means just location wise it is in different. Okay. 0, 1, 2, 3. If you write the 0 up to 3 means the locations will be 0, 1, 2, 3. Like that. The location will be changed, order of location. And here's 8-bit value, it will be stored. If there is only single bit means no need to put the vector format. That is scalar format. Okay, that is a reg data type which stores the data. Mainly we will use for sequential logic circuit. Whenever you want to declare the output, we will use the reg. Okay, and I told you whenever we are using the procedural assignments like always, initial, that case we need to declare output as a reg data type. Okay. Next, non-synthesizable data types or integer. Integer writes 32-bit data. Time is nothing but you will write $time in test cases to mention the delays, right? For that case we will use the time data type. Next, real is nothing but in C language you will use float value. Float value is nothing but decimal values. Okay, so that thing we will call here as a real. Okay, these are the non-synthesizable data types in the Verilog. We'll see one example. Integer A, real B, times C. For integer, we are assigning some 32-bit value. I already told you here in Verilog, we will define like this. If you want to define a 2-bit binary, like 2-bit tick B 00. If you want to take 4 binary variables, then 4-bit binary 0110. Like that, decimal in place of B you need to put decimal. If you take like that, here hexadecimal 32-bit we have taken, so 32 tick H and some value we assign, and B equal to some decimal value assigned, and hash 20, whatever the hash 20, whatever the delay is there, the delay will be assigned to the $time. That is nothing but C, and we displayed all the variables here. Okay, if you see here, there is some change we need to make. What change required here? Can you tell me? What change required here in display statements? Can you tell me? Hello.
No idea.
No idea. Just observe.
Yeah. Yeah.
Other guy. Hmm. Okay. Okay. Just see here. I will show you. Wait. Hmm. Okay. If you observe here, A equal to 32-bit data. Okay. We have taken in a decimal. Decimal value is getting accordingly. Here float value. Again we took in decimal. The format specifier %LD. That means a decimal. Okay, and $time is okay, decimal it will be print. Okay, so 20 we got correct output for 20 only, remaining 2 we didn't got. Okay, exact value. So for that purpose what we need to do, for hexadecimal we need to put H. Okay, format specifier. For the floating value, we need to put G, percentile G. Okay, those things you need to modify here. H and G. Now run. Okay, if you see whatever the values we have taken here, integer data type, we got correct value, and for float data type like a real, we got correct value, and for C, 20. Okay, see here there is a more distance. Okay, you can minimize this distance. Whenever you got like this, you can minimize the distance by putting simply width here, size width. Just 0 I am taking. That means minimum width. You can take 1, 2, or 4, like whatever the value based on the distance you want. Okay, see, now we got all values in a order. Okay, so this is how these are the different data types we have, which are non-synthesizable. These things we cannot use for designing. We can use only for test bench. Okay, clear? Any doubts?
Yeah.